Hello everyone. In this video I will be explaining my solutions to all the problems of LeetCode Weekly Contest 300, and the difficulty of this contest was relatively easy when compared to the previous LeetCode Weekly contest. And yeah, let's start with the first problem. And the flow of the video will be I'll be quickly explaining the algorithm, and then we'll be walking through my code. Yeah, so the first question is decode the message. So in this question, basically we are given a message and we need to decode this message, and we need to map each character with another character. So that mapping will be obtained from this key, and the way in which we obtain the mapping is whenever we see a first character, the character which is occurring for the first time in the string key, we say that character is the mapping of ith character from A. For example, since T is occurring first for the first time here, T maps to A. Similarly, H, E, and so on. Let's say there is another T before Q. In that case, that T won't be considered, and Q will be again mapping to D, and spaces will map to themselves. And yeah, basically spaces will be mapping to themselves by default, so you don't have to take care of that. And yeah, once we find this mapping, we just have to replace all the characters in the original string which is message and return the answer. Yeah, nothing else. Constants doesn't matter here because the first problem will usually involve a brute force solution. So yeah, let's see the solution. I'm using a map here. You can use a integer array as well. It's up to you how we implement. Yeah, so as I said, we have a pointer which represents the current character, and another loop for iterating over the key. And if the current character is a space, or if it's already met, you don't need to do anything. Move on to the next character. So if the current character is new and appearing for the first time in the key string, put it inside the map and increment the current character, and then go through the message and replace each character. So if it's a space, replace it with space itself, or else replace it with its mapping. That's it. Yeah, so the time complexity of this solution would be order of n 26 times n, because the time complexity will be order of n log of 26, because at most 26 characters will be here, but if you use an array, it will be linear only. Yeah, in this problem, time complexity doesn't matter much. Yeah, let's move on to the next problem. Yeah, in this problem, spiral matrix. So we are given two integers m and n, which represents the dimensions of the matrix, and we are also given the head of a linked list, singly linked list of integers, and we need to generate a m cross n matrix that contains the integers in the linked list present in a spiral order, clockwise, starting from the top left of the matrix and circling throughout the matrix in a circular way. And if there are few empty places in the matrix, you have to fill them with -1. Yeah, and you need to return the generated matrix. Okay, so basically this array head is given in form of a linked list, nothing else, and m and n are dimensions of the matrix, and we need to return a matrix of dimension m cross n. So I'll in my implementation, I'll be swapping m and n to be consistent with my style of coding, but it's up to you. So here, after n represents the number of rows and m represents the number of columns, and the way in which we do is you can see first we start if we traverse the first we create a 2D matrix of n cross m, and then we start filling we initialize all the values as -1, right, so that those empty spaces get initialized beforehand, before solving anything, before filling the remaining areas, right. and then start from the cell 0, 0 and go in this way, like traverse the border, outer border, and then once you come here, you go to the next layer of the border, we can say, and then continue the process, right? So just to have a better visualization, if we have a matrix like this, right? Yeah, first we'll start from here. We go here, we again go here, again go here. Let me put it in different. Yeah, first we go here, then we go here, we go here, and we come here, right? And then once we come here, we move on to this cell. Again we follow the same process. We go here, we don't go to the next one because it's already covered, so we jump below, we again move here, we come here, right? So again once we come here, we have to start from here. So be a new starting point, and since I cannot go anywhere right, I have to go below. That's it. So this is how we have to traverse the entire matrix. So we can make few observations here that if the dimensions of the matrix are n cross m, the total number of these points, starting points, are equal to minimum of CL of n by 2 comma CL of n by 2. So total number of starting points is this value. You can verify it with pen and paper. And then so the implementation will be like, we'll iterate over all the starting points, and then we do this traversal for each layer, right? Because each layer is independent of the other layer. So for each starting point, we'll do this traversal, and yeah, we basically fill out the matrix till we can. Okay, right. And then one more thing to note here is this: during the traversal, once we have the starting point, we have to, in each layer, we have to define where we should end and start in each direction of the traversal, right? First, whenever we have a starting point, we first go through in this way from left to right in the first row. Then we go from top to bottom in the last column. Then we again go from right to left in the last row, and from bottom to top in the first column. And we are not exactly starting at the like corner cells at each point, right? You can see in the first iteration we started here, we came here, and to continue this traversal, this from top to bottom, we have to start from here. So it's not clear that it's not well defined that each corner is a starting point or ending point, so it can be different also. So in this case, I continue this till here, and then I start this traversal from this point itself, from this cell. So we can see only the first cell starts at the corner point, basically this principal diagonal. So other cells don't start at the corners. So next we go here, and then this traversal starts at this cell, and it ends at this cell, right? Okay. Similarly, this traversal started here and it ended here. This traversal started here, ended here. It started here, ended here. Yeah, we can get the idea. So basically, these are the cells which are starting and ending points for each layer, you can say. So these are the starting and ending points in each layer. So while doing each of these traversal, we traverse from that particular start point and end at that particular end point, and we do this for all four directions. All four directions we do, and then whenever since the input is given as a linked list, whenever we get to the tail of the linked list, which will be a null node, right? Basically the next of tail, you can say tail dot next. Whenever we come to tail dot next, we'll break out from the traversals and we'll return the matrix. So yeah, that will be the implementation. That will be the algorithm, and the implementation is as follows. So initially we create a matrix of size n cross m. I am basically swapping these values here itself. And yeah, as I told, the total number of start points will be minimum of ceil of n by 2, ceil of m by 2. That's this. So ceil of n by 2 and m by 2 can be represented like this: n plus 1 by 2 and m plus 1 by 2. And yeah, and then yeah, so basically we'll be doing four traversals for each of the direction, right? First this traversal, and then top to bottom, and then right to left, and bottom to top. In this way we'll be doing. And the first iteration, it starts from this cell 0, 0, right? But how do we generalize this? So we can observe a pattern here that every cell so every starting point is present at the principal diagonal, right? Main diagonal, right? So each point present at the principal diagonal can be represented by I comma I. So starting point is I comma I for the first direction traversal, which starts from left to right in the top row, and then it ends at it goes till the column is lesser than m minus I, right? So m minus I is nothing but you can say the next of this cell, right? Because m represents this column represents m minus 1, and we can say the hypothetical column which is present after this is at the index m, and we are saying m minus I. So when we are at the first level, m minus I will be m minus 0, so lesser than m minus 0 will be same as iterating through all the columns in the first layer, right? So yeah, these are just implementation details. We can find this by just doing simple math only. And yeah, and of course in all the loops we have to break whenever we see whenever we go to the end of the list. So add this to all the iterations, all the traversals, and yeah, and traverse over the matrix and assign all the linked list values, and traverse the linked list as well simultaneously. And the second traversal starts similarly here from this cell. So this cell is represented using r equals I plus 1 comma c equals m minus I minus 1. So r equals I plus 1 and the c represents the ending point of the starting point of all layers in the second traversal, right? So it will be these values, this one, and if there are more columns, we'll go on saying these values. Okay, yeah, and the same appears here, just like how we said m minus I, here it's n minus I, and now we are iterating over the rows and coming on to the third traversal, which happens in this direction. So the starting cells will be these cells. If we have more cells, we can go on if we have more rows, we can go on like this, but in our case only these two cells. So these two cells will be represented using this formula: r equals n minus I minus 1 and c equals m minus I minus 2. Yeah, and then we'll be iterating till I, right? Yeah, think it should be greater than I think there is a think they have weak test cases because it should be greater than I, because you shouldn't cross the ith column, right? Second. Yeah. No, correct. Yeah, actually it's greater than or equal to I only because the third traversal is going from bottom right to bottom left, right? So it starts from here and it goes till the first column of that layer. So in the first layer it will be this column, in the second layer it will be this column, so it will be greater than or equal to I only. Yeah, the same thing happens here. I iterate over the columns, assign the values, and then similar to how we set m minus I minus 2, same applies here. R equals n minus I minus 2 and c equals I. Yeah, same thing happens, and then we return the answer. Yeah, that's it. Let's move on to the third problem. Yeah, the third problem was kind of tricky for me, at least. Like, I solved the fourth problem only, then I went on to solve the third problem. Yeah, so let's see. Yeah, actually the constraints are given in a way that n square solutions can pass, but I was thinking and I was coming up with a linear time solution only because I knew that we should be using prefix sum somewhere. So yeah, let's see what the problem is. Yeah, so basically we have a secret message, and initially only one person knows that message, and then we are given two values like delay and forget, and then each person who knows the secret will be able to share it to one more person on any given single day, right? That's the thing here. And then the person who knows a secret, who gets to know a secret, can only share it after a certain number of days, that is delay. And then once he gets to know a secret for the first time, after these many days, after forget number of days, he forgets the secret. So there are multiple things happening here. So first he gets to know the secret, and then he can share it for these number of days, and then he forgets. So three types of events happens here. Okay. And then and one more thing, a person cannot share the secret on the same day and then forget it or any day afterwards. Yeah, basically if the person forgets a secret on a particular day, he cannot share any secrets that day. He cannot share that secret. So there's that day is meant for only forgetting the secret and nothing else for that particular person. Okay. And we are given n. We need to return the number of people who know the secret at the end of the day, n. So after n days, we need to determine how many people know the secret. And since the answer may be large, we have to return it modulo 10 power 9 plus 1. Okay. So yeah, the first case, the example is very obvious. Even the second case is very obvious. But doing it with pen and paper, only after that I was able to come up with the correct solution without implementation errors. Yeah, the only thing here matters is you need to know who knows the secret message at each particular day till the end of the day. And then not only that, we also need to know who can share the secret message to other persons, and then those persons which are just which just got to know from the previously known persons, they can again continue the process. Basically this is kind of a chain reaction, and this chain reaction happens throughout. That's why the number of people can be very large. Yeah, let's see how this happens for the first case, right? Like after seeing this first case, the solution was very obvious. So yeah, let's see the first case. Basically, when I was solving, I drew a table for this question. Yeah. So the table was like this, and in the problem itself, we can see that we have up to 6 peoples. So I am creating all the peoples A, B, C, D, E, F, right? And then we have days from 1, 2, 3, 4, 5, 6. We have 6 days. Okay. And we can just simulate the whole process here and see, like, we can observe the pattern what's happening here. So on the first day, only the first person knows the message, right? So he knows the message on the first day. Okay, right now he's not able to share it till some date, right? On the second day, we can see again he only knows the message and nothing else happens, right? So we can say, we can just put dash for the remaining things. Okay, on the third day, person A can share the message because he got to know the secret on the first day, and after 1 plus 2, after 2 days from the day he got to know, which is the third day in this case, he can share to the new person B. So from this day, he's like, in my implementation, I am calling these days as creators, but we can also call it as shares or something. And then the person B gets to know the message for the first time, and no one else gets to know about anything. Okay, this one. And then on the fourth day, again a person A shares the secret with one more new person C, right? So on the fourth day, still he's a creator, and B still knows the message, knows the secret, and C gets to know the secret for the first time. Cool. D, E, F doesn't know anything till now. Okay. On the fifth day, F forgets the secret because 1 plus forget is 4, which is 5. So on the fifth day, the first person forgets the secret. So he doesn't know the secret anymore. Okay. And B still knows the secret, but let's see what happens. And then the fifth day, B shares the secret with the new person D. Okay. So B is becoming a creator on the fifth day, and C still knows the message, and D is getting created for the first time, and he is getting to know the secret for the first time, and EF is again empty. On the sixth day, again A can't be created because he forgot the message, and yeah, let's see what happens. B again shares the secret with E, so he's a creator again. So this terminology might be confusing. So K means the person knows the message, and C means basically he's able to share the message. So here C represents creator, but yeah, can consider it as share. And yeah, sixth day B shares the secret with E, so E gets to know about the message for the first time, and then C shares the message with F. Okay? So F also gets to know about the message for the first time, and D and F stays the same. D and C, yeah, actually C, since she shared since C shared the secret, C has become a creator. So yeah, so this is the table actually. So once we draw this table, like, everything will become clear, like how is this happening from each day, right? Yeah, we can see initially only one person had the information about the secret, so he knew it for some days, and then he became a creator, right? Similarly for B, similarly for C, similarly for everyone. Okay, so we can say that whenever we talk about whenever we create a new person, he gets to only know about the secret for a particular amount of time, right? That particular amount of time is less than or equal to delay. You can verify it everywhere. And then he gets to become a creator, right? And that is less than or equal to a forget minus delay. The number of days he gets to become a creator and the number of days he gets to know the message. So these two are important things here. And the days from which the knowing period starts and ends can be easily found using the given details. Like for example, in the first day is the first time the person A is getting to know about the secret. So from the first day till delay, right? Open interval, closed interval 1 and open interval delay is the time frame during which the person A gets to know about the message, right? And then again what happens is he's able to he's able to share the message from starting from day 1 plus delay. Like all these 1 to 1 plus delay. Yeah. Actually 1 plus delay 2. So it's not 1 plus delay because it starts from 1 plus delay, right? So this value represents 1 plus delay. So he's becoming a creator he's being a creator in this range. Closed interval 1 plus delay, comma, till we can say 1 plus forget, right? Because 1 plus forget will represent this value. So open interval, closed interval 1 plus delay, comma, 1 plus forget, open interval. Okay. So the same applies for all the persons. The only change we have to make here is, since the person A gets to know about the message for the first time on day 1, we are adding day 1 everywhere. But what about the person 3? The person 3 gets to know about the message on day 3, so we'll be adding day 3 here everywhere, right? So this is the duration in which he is being able to share the messages. So the same thing applies for the knowing period as well. Like we just saw before, the knowing period is just the first time he gets to know about the message that particular day D plus that particular day D closed interval to D plus delay. That's it, right? And then from that D plus delay closed interval, we are starting here and continuing till basically it's a continuous interval, right? And there is a we can say there's a pivot point here. So the same applies for all the persons. And yeah, you can see on day 6 we have to return total number of persons who knows the message. So on day 6 these persons know the message. You can see 3 persons only know the message, but 2 persons can share the message, so hence they can also know the message. So 5 is the answer on day 6, which is the correct answer. And the same applies for example 2 as well. Yeah. And the way in which we keep track of the number of number of persons who knows the secret and number of persons who are creators is using 2 different concepts. The first one is prefix sum, which is like it turns out to be an optimization to this problem. The second one is the difference array, and obviously we can do this problem without both of them. Like we can use 2 for loops and then do all the stuff, but since I was aware of these 2 techniques, I was using these 2 techniques. Okay. Yeah. The way in which we do this, so using a difference array and prefix sum helps us get the linear time complexity for the solution, or else we can do n square as well, so that won't be a problem here. Yeah, so the constraints were very light for this problem. Okay, and again we need to return it model temporal. Yeah, let's see the implementation. Yeah, as I told, I have created 2 arrays, knows and creators, and in the end I'll be returning the persons who knows the message at the day n and who are creators at the day n, and of course I have to take the modulo. Yeah, let's start with the first message which we have at day 1, and yeah, he knows the message on day 1. You can see here he knows the message on day 1. So we have one person who knows the message on day 1, so incremented, and then he knows the message till this particular interval, right? That interval here will be the same, d plus delay, and that should be, yeah, so this is how we do the difference array. Like for example, if we have a range L comma R and we want to update this range L comma R with the value R plus X, we do difference of L plus equals X and the difference of R plus 1 minus equals X, and then we take the prefix sum of the whole array, and then after that each value difference of I will represent the final updated value of the array, right? But in our case you would have noticed that all the intervals are semi-open intervals, right? So in our case the intervals will be like this. So here instead of R plus 1 we'll just do R. So yeah, that's one thing to notice. So hence you can see the first ending point here is d plus delay, so d plus delay minus minus, so this person can only go till this state d plus delay, and then yeah, this is just modular arithmetic. If it becomes negative I will add the mod, and then yeah, and then his creation period starts from the next day itself, right? D plus delay. So yeah, I'm also doing that here, updating that here for the first person. So all these things are only for the first person, and then again the forgetting period starts from here. Same applies here. Again I'm subtracting, taking the modulo, and then yeah, and then once I update the information for the first person, so this is essential because only using this information we'll be able to create the remaining persons. So yeah, so this is kind of a pre-processing step, and from the then we iterate over all the days from 1 to n, and in each day, as I said, the reason in which why we get the linear time complexity is by using the difference array and prefix sum, right? So before doing anything with these two arrays, we have to update these two arrays with the current value, right? So this is how we do that. We just take the prefix sum of both the arrays. So here both the arrays acts as a difference array actually, and in the end after we take the prefix sum of all the values, it turns out to be an array with our like desired answer. So we're doing multiple things in only two arrays, so we have to keep that in mind as well. Yeah, this is just taking the prefix sum, and then yeah, the current number of creators is X, total number of creators which are present at the current date D, right? And then yeah, and then once I have this count, what will happen is all these creators on this particular date, they can they can increase the number of knowing, like this means we have X creators on this particular date, so each creator can share the secret with one other person, like one new person. So everyone will share the message to one more person, and totally X new persons will be created. So I'm saying the total number of persons who gets to know about the message for the first time will be the ones who already know at this current date plus X and all, like everywhere. Of course you have to take modulo, so it's there. And then again the pre-processing stuff, we have to mark the delay and forget period for each of the persons, right? Each of the persons we have added till now, like right now we have X creators, and the X creators have created X more new persons, and we have, whenever we create a new person, we have to update their we have to mark their periods of like knowing period and ending knowing period and creation period, right? So that's our duty in this loop. So only if we do all this simultaneously we'll be able to achieve this linear time complexity. Yeah, so the same logic we had here for person 1. Instead of decrementing and incrementing with 1, I am doing it with the x. That's the only difference here. And yeah, of course, in the end we'll just have to return the number of persons who knows the message and number of creators at that day, end of the day, and modulo everywhere. Yeah, that's it. This is the third problem. Let's move on to the fourth problem. Yeah, so this problem we have another m cross n grid. So in every problem I'll be using n cross m only, even though if they give any different weird notation, be it w cross h or m cross n or anything. So n cross m is the notation I use to represent the grids, where n represents the number of rows and m represents the number of columns. And we are given that we can move from a cell to any adjacent cell in all 4 directions. So this means we can move up, right, down and left. And so we have to return the number of strictly increasing paths in the grid such that we can start from any cell and end at any cell. So there's no length restrictions for the increasing path. So only restriction is the paths should be strictly increasing, which means every subsequent value should be greater than the previous value, right? And then again we need to return the total number of increasing paths, which will be very, very huge. So we need to take modulo again. And then 2 paths are considered different if they do not have exactly the same sequence of so basically this will be like usually covered. So we don't need to worry about this case. In implementation, this will be usually covered automatically. Yeah. So let's see this example. We have a grid and the total number of strictly increasing paths are 8. So you can see the paths with length 1 are all the elements itself, and then 1, 3, 1, 4, 3, 4 are length 2 paths, and then 1, 3, 4 is the length 3 path, right? So the total number of paths will be 8. Cool. Similarly for this case, we have 3 for 1, 2, and then 1 to 2. Okay. So this problem for me it seemed very straightforward than the previous problem, the third problem, because this is just like standard DB, standard DB on grids. Let's see how to do this. Yeah, so we know that this problem is a DB problem, and yeah, the constraints are also like pretty standard. We can get to know from here. There are about 1000 and m cross n won't cross 10 power 5, and each value can be, so this doesn't matter. This is just for comparing the values, so we won't be adding anything here. And yeah, so from the constraint it's obvious that the expected time complexity is order of n square, so which means our dp function will have 2 state variables, right? In this case it will be dp of I comma j, where dp of I comma j represents, so this will be, let's just straight away jump into a dp solution. I'm assuming that the recursion and the brute force solutions are obvious. Like the obvious solutions are just to like explore all the paths and prune those paths which are not strictly increasing and have a counter. That's it. We can do it using recursion and it will have a exponential or factorial time complexity. And we have to we can see like there are many for example, let's just convince ourselves first dp, we can apply dp here and then move on to the dp solution, right? You can see we have a 1 1 3 4, and if I want to know the total number of strictly increasing paths which starts at this particular cell, I will make a call to the neighboring cells, right? Because I can move to any adjacent cells, and I can only do so if the that particular cell has a greater value than my current cell, right? So I will make a call to this function, and I will make another call to, like, this function will make another call to this cell, and it will go on, right? So after some time we can know the total number of strictly increasing paths starting at this cell will be 3, which is 1 1 to 3 and 1 3 4. Okay, so what happens from here? Like, when I say okay, this is done, when we are talking about this cell, similarly when I talk about this cell, total number of strictly increasing paths will be 2, which are 3 to 4, and which are 3 and 3 to 4. So we can easily see that these are subproblems, like recurring subproblems, right? So similarly, even for a 2x2 grid, we have identified a recurring subproblem. So for big values of n and m, there will be a lot of subproblems, like overlapping subproblems, not recurring subproblems, overlapping subproblems. So the thing is, if we know the answer to these subproblems, we can find the answer to the whole problem, right? So that's the gist of dynamic programming. Yeah. So now that we are convinced it's DP, let's go on to solve the problem using DP. Yeah, the first thing while solving a DP solution is defining the state. So in this case, DP of ij will be the number of strictly increasing paths starting at cell I, j. That's it. And the answer to our problem, so the answer to the whole problem will be the total number of paths in the grid which are strictly increasing and which can start and end at any cell, right? So there are n square cells in n cross m cells in a grid, and we can start from any cell. So answer will be summation of dp of double summation of dp of I, j, where I equals 0 to n minus 1 and j equals 0 to m minus 1. That's it. And the base case, like, obviously our DP solution should have a base case, only then it can terminate. The base case will be when we what will be the base case, right? Base case will be the smallest possible input. In this particular case, we can see that 4 here is the base case. Why? Because from 4 you can't move anywhere else, right? So because from 4, in order to move to any adjacent cell, that particular cell should have a value greater than 4, but in this case we don't have any such cell. So 4 is the base case for this particular grid. Similarly 2 is the base case for this particular grid, right? So any particular grid, or to be precise, if a cell I, j is a base case, if all the surrounding cells of I, j have strictly smaller value than the current cell I, j, right? In that case, all 4 adjacent cells should have values lesser than 4. That's true here, so 4 is a base case, right? So since this is a counting problem, usually in counting problems with DP, we'll run 1 in the base case. So that's same. And as I said, the transitions are also really obvious and standard. This is same as doing the grid problem, wherein we have to count the number of ways in which we can reach from 0, 0 to n minus 1, m minus 1, right? Number of ways we can reach from this particular cell to this particular cell by doing only a down and right operation. So same way here, since here we only have two operations, it will be like dp of I comma j, dp of I minus 1 comma j plus dp of I comma j minus 1, like that. In this case it will be, since we have four possibilities, like from I comma j we can go to four different cells, so we can say dp of I comma j is dp of I plus 1 comma j plus, we have to add plus because we have to count all the number of all the paths in each of those possibilities. So dp of I comma j plus 1 plus dp of I comma j minus 1 plus dp of I minus 1 comma j, right? So these four dp function calls represent the four adjacent cells, and of course for all I comma j are all valid I comma j. So valid here represents the that all the cells here should be within the grid, right? They should be within the grid, and the new cells, the values at the new cell should be strictly greater than the value at the current cell. So the validity represents these two things. So yeah, that's it for the DP part, and now it's just the implementation part. So the way in which we do these kinds of problems, so this is somewhat similar to DFS on grid, but we'll be using memoization here to cache the answers to those overlapping subproblems, right? Yeah, that's the only difference between DFS on grid and this implementation. Yeah, let's start from the beginning. We have a grid and I have a visited array of maximum possible dimensions given, and then I have two direction arrays, and then I have a mod value, and then the memo, and I have a helper function to check if any given cell is valid or not. As I said, it should be inside the grid. So basically this function just says whether the given cell is inside the grid or not. And yeah, let's see the main function. Here we just initialize all the values, and then we iterate over all possible starting points, which are I comma j, and then we just add the total number of strictly increasing paths starting from I comma j to our answer, and of course we have to take modulus everywhere, right? Okay, so the dp of I comma j, as I said before, is defined the same way. So x and y will be variables and n and m are constants, and if we have already visited this particular subproblem, this particular state, we can return the memoized value. If not, visit that cell, initialize the cell with 1 as answer because that particular cell itself is a strictly increasing path of length 1, and then for all the adjacent cells, the new cell will be represented in this way: nx equals x plus dx of k, and ny equals y plus dy of k. And if it is inside the grid, if the new cell is inside the grid and the new cell has a greater value than the current cell, this is a valid cell, so we can go to that cell and explore the total number of paths over there. So add that to the answer and cache the result before returning. That's it. So yeah, this is the top-down implementation, and we don't actually need the visited array here. We can actually do this solution using only memo array itself. You can just initialize everything as -1, and then just like how we do in like classic DP problems, we can do. Since it seemed like DFS, I created this array, but the implementation is the same. We can just remove this thing and replace this with if memo of x comma y is not equals to -1, and that will be the only difference. And yeah, and we don't need this visited array. Yeah, so that's it for the solutions. Yeah, overall the difficulty of the contest was comparatively easy. as you can see from the total number of accepted solutions for hard problems. Yeah, that's it. Thanks.